As the last few videos have shown, psychologists collect a large amount of data in their investigations. In fact, with lots of participants, the amount of data collected, known as raw data, can be overwhelming. And it can be hard to tell a clear story about what exactly was found in a study. That's where descriptive statistics come in. These are simply the statistics that summarise, meaning they describe certain features of a quantitative data set, like what the average score is or what the spread of the scores in a dataset is. The term descriptive statistics sounds a little scary, but in reality you likely know what they are. Descriptive statistics include both measures of central tendency and measures of dispersion. Measures of central tendency include the mean, the median, and the mode. So, measures of central tendency are averages. Measures of dispersion refer to how spread out the individual scores are. So, this includes both the range and the standard deviation. But be prepared. If a question ever asks about descriptive statistics, measures of central tendency, or measures of dispersion, you need to remember what calculations those terms are referring to. Psychboost.com, over 170 videos to help you with your qualification, and Patreon supporters can access bonus resources, tutorial videos, and the Discord channel. Measures of central tendency. To understand the difference with measures of central tendency, let's imagine you're going for a job interview at a small company. And they ask if you have any questions. And reasonably you ask what the average wage of the people who work at that company is. The CEO is interviewing you, and he has a list of all the salaries of the company employees. Let's say it's this set of data. 10,000, 15,000, 15,000, 15,000, 20,000, 24,000, 24,000, 26,000, 36,000, and 195,000. The mode. Let's start calculating measures of central tendency with the simplest, the mode. The mode is the most frequent score in a quantitative data set. So you can see, in this data set, the mode is 15,000. There can, in some sets of data, be more than one mode. If there are two modes, we'll call that data bimodal. And if there are more than two, multimodal. Positives of the mode are it isn't affected by outliers, meaning it's particularly useful for discrete numbers. For example, it can make more sense to say the average family has 2 children than 1.89 children. And if the data is in categories, like average pet choice, giving the modal group is the only way of giving an average. However, a criticism of the mode is in small data sets there are likely to be multiple modes, or even no mode if every score is different. So not given a clear average value. It also doesn't include all the values in its calculation, so it's not as sensitive as the mean. Median. The median value is calculated by ordering the values from the lowest to the highest and using the number in the middle as the average. If there are an even number of data points, then take the two middle scores and it's halfway between the two. So in this case, the median value would be 22,000. Positives of the median are it's not affected by extreme outlier scores. Unlike the mode, it's very easy to calculate. However, criticism of the median are not all the raw scores are used in its calculation. So we'd say that it's not as sensitive as the mean. The mean. So to work out the mean, we add all the scores together, which gives us 380,000, and divide by the number of scores, in this case 10. So in this data set, our mean average salary at this company will be £38,000. Positives of the mean are we have used and represented all of the raw data in its calculation, so we would say it's sensitive. However, the main criticism of the mean is because of its sensitivity, it's easily shifted towards extreme values. Now, going back to our scenario, the CEO would be perfectly accurate in giving any of those figures as the average wage of the company's employees, and might be tempted to state the mean to show his company in the best light and to get you to join his company. And you've probably noticed this careful selection of descriptive statistics is often used by politicians and companies to spin and misrepresent their policies. So because of their contrasting strengths and weaknesses, the correct measure of central tendency should be used for the right situations. Measures of dispersion. The range. As measures of dispersion are about the spread of a set of data, the range may be the first you think of. It's easy to calculate, you just take the smallest value from the largest to get the range. Using our example, 195,000 minus 10,000 gives a range of 185,000. Some of you may have been told to add 1 when working out the range. That's fine, it's also an acceptable way of stating the range. Well, a positive is the range is clearly very easy to calculate. However, the main criticism of the range is extreme scores easily distort its value, and the range doesn't show if the scores are more spread out or are clustered around the mean. Standard deviation. The standard deviation is a much more complex calculation and gives a value that shows how spread out or clustered the scores are around the mean value. Now, while calculating the standard deviation is outside of what you need to know for your course, we do need to understand how to interpret the value of the standard deviation. The main thing to keep in mind is the bigger the standard deviation, the more spread out the scores are. Let's say we have two classes of 10 students taking part in a study, and at the end they take part in the same 50-question quiz. These are the scores for each student, and these are the standard deviations for both groups. From these standard deviations, I would expect you to be able to tell me that Group 1 has scores that are more consistent than Group 2. Or, put another way, Group 2 scores are more variable than Group 1 scores. Positives of the standard deviation are it includes all values in its calculation, unlike the range. However, the standard deviation is still distorted by extreme values and is more difficult to calculate than the range. Percentages. Percentages are also a way of describing data, and we can be asked in the exam how to calculate percentages. You may already know how to calculate percentages, and in that case, keep in mind that when you see a percentage question in your exam, you may need to explain what that percentage means rather than just stating what the percentage is. But you can skip this next bit if you know how to work out a percentage. Grab your calculator, you're allowed one in your A-level psychology exam, do not forget it. What follows is how I calculate percentages. There are a few ways and you may have been shown a different way that makes more sense to you, and that is fine. Firstly, let's cover how to calculate the percentage of any number that we're given. In this example, the psychologist is conducting a stratified sample for a questionnaire. Her target population is all of the students at a large further education college. She knows the full population of the college is 2,480 students. 595 students are studying for A-levels, 1,389 students are studying for BTEC qualifications, 288 students are only attending to retake GCSE, and 208 students are adults taking access to university courses. What is the percentage of each subgroup, and how many of each group should she include in her sample of 250 students? You may know that percentages can also be expressed as a fraction or a decimal. In this case, we have both parts of the fraction that we need. Because for our percentage, we want to know 595 out of 2,480. So let's write our fraction as 595 over 2,480. We can convert this fraction into a decimal by dividing, and here is my calculation. Now we have the fraction as a decimal. To turn this decimal into percentage, we times by 100, or more simply, we just move the decimal place over to the right twice. I'm going to round this up, and we get to 24%. Pause this video and try the same calculations with the other groups. Here are the percentages. Secondly, let's see what we need to do if you need to find the percent of a number. So you now know that the sample in the study is 250, and we need strata that are 24%, 56%, 12%, and 8% of this number. Well, the easiest way to work it out is to turn the percentage into a decimal, and then times the decimal by the number of participants. So we can work out 24% of 250 by multiplying 0.24 by 250, giving 60 participants who are in our A-level strata. And here are the answers. I may want to talk about the percentage difference between two numbers. Let's say next year the questionnaire is repeated at the college and the number of A-level students at the college grew to 724. What's the percentage change in the number of A-level students from one year to the next? Well, to work out the percentage change between two numbers, subtract the old number from the new number, so 724 minus 595, and then divide this by the old number. Then times this by 100. That gives us an increase of 21.7%. Let's say the number of BTEC students reduced from 1,389 to 974. Using the same calculation, we get minus 29.9. Of course, the minus means there's a decrease in the number of BTEC students. Okay, I hope that helped with calculating percentages. Correlations. Correlations are also descriptive statistics, but of course we covered positive and negative and zero correlations, as well as the correlation coefficient in the correlation video. If you'd like a reminder of what they are and evaluations of the use of correlation, jump back to that video. I have 8 tutorial videos covering the AS and A-level research method sections from 2017 all the way to 2020. These videos have worked examples to every question and are full of exam tips. Patrons at the neuron level and above can access these, as well as many more hours of exam tutorial videos, as well as over 100 printable resources from across the A level over on psychboost.com. I do want to thank all the students and teachers who've supported PsychBoost over on Patreon during the development of the Research Methods unit. It's their support that allows me to teach part-time, so I can make PsychBoost on YouTube for everyone. I also want to give a special shout out to the patrons who support me at the developer level. So thanks to them, and I'll see you all in the next Research Methods video.